Hello everyone. Today we're going to talk about the Pythagorean theorem and a little bit about square roots. So the Pythagorean theorem is a squared plus b squared equals c squared, where a and b represent two sides of a right triangle and c squared represents the hypotenuse. So what am I talking about? So a right triangle is a triangle that has a 90-degree angle here. This square is like a 90-degree angle. So what's important about a 90-degree angle? Well, if you look at a circle and divide it into four squares like this, you'll have each one of these angles here would be considered 90 degrees. So another interesting property is because it's divided so evenly like this, you'd imagine these two lengths are the same, right? But the thing with 90-degree angles is that you can also have something weird, like something like this happening, where this length is clearly longer than this length here. But I digress. The point being is that this Pythagorean theorem, what it expresses that if this angle here A, let's call this angle here B, and the longest angle that connects these two angles, which is perpendicular, which is on the opposite side of this 90-degree angle, is called C. This is also called the hypotenuse. But the point being is that a squared plus b squared of these two lengths will always equal c squared. So what's an example of this? Let's say a square, let's say we have a triangle that looks like this. The length here is going to be 3, and the length here is going to be 4. I didn't draw it on scale, but let's pretend this length is longer. So let's say we want to say, what's the length of this angle here? C. So we'll know that a squared plus b squared equals c squared. A squared is going to be 3 squared. B squared is equal to 4 squared. And c is going to be equal to the square root of the sum of both. So 3 squared, that's going to be 3 multiplied by itself. That's 3 times 3 equals 9. And then 4 squared is going to be 4 multiplied by itself. 4 times 4, 16. Equals c squared. Adding them together, it's going to be 25 equals c squared. And then we can take square root of both sides. C would be equal to 5 and -5. Positive 5 and -5. But we're obviously going to take the positive number because we can disregard the idea of a negative length in this perspective here. So with this idea, you can find the length of any part of a right triangle as long as you have two of the sides. So let's have another problem where the length here is 16. The length here is, let's say, 81. And the length here is 20. And well, let's not say that. Let's say the angle here is B. We want to solve this angle B. So we know that a squared plus b squared equals c squared. C is going to be 81. B is just going to be itself squared. And a is going to be 16 squared. This is a bit trickier one since we're using bigger numbers, but you'll figure out sooner or later that 16 squared is 256. And then b squared is going to stay the still. And then 18 squared, well, 81 squared, I mean, is going to be 6561 by subtracting 256 on both sides. We're going to get b squared is going to be equal to 6, 3, 50, 6305. Yep, that looks to be right. And so this is essentially, sorry, 6305, and then b squared can just be square root of 6305. Now let's get into the idea of square roots and all that, and how to estimate them. So essentially, a lot of problems, they'll ask you to approximate a square root. Let's say we take the answer from this problem. Let's say we want to know like a good enough answer to understand what square root 6305 is equal to, right? So one analogy we can understand about square roots is let's say we have two square roots, square root 4 plus square root 4. Square root 4 is going to be equal to 2. So this is equal to 2 plus 2 is 4. And this is equal to also square root 16, because square root of 16 is also equal to 4. So when you're adding two square roots together, you can multiply the numbers inside, the 4s, and you can get square root like this, right? So this is something that you can kind of understand. Now let's talk about 6304 for a second. So let's first think of a square number that can be close to it, or at least somewhat close to it. So let's do 80. So 80 squared is going to be 6,400. So that's a bit close, but I don't think that's close enough. So let's do 79 then. You can use your calculator for this, or your teacher, if you're really mean, they can make you solve it yourself. But 79 squared would be equal to 6,241. Well, that's not very good to work with. But we can approximate that this number would be square root of 3605 will be at least equal to 79, because it can't be 80, because 80 would be too big for it. But it could be 79 point something, right? And now you would have to just approximate using guesswork here. Let's say we can do 79.5. So 79.5 squared, you can use your calculator for this. 0.5 squared is going to be, oh, this is pretty close, 6320.25. And then 79.6, we can write 79.6 squared is going to be 6336.16. So again, because 633.16 is too big for 6305, it's probably going to be 0.5 because it's 6320. Oh wait, 6320 no, 0.5 is also too big. So we're going to have to move down to, let's say 0.3 for a second. Uh, this is just a lot of guesswork. Point three is 6288.49. And then let's double check with 4.4. Point four will be on the dot of 63. Okay. So, so this means that square root 6305 is likely closest to our estimate of 79.4 squared, around that much. And then basically you can repeat this procedure to find the next digit, and then and to as many digits as you want, as close as you want to it. So this is essentially the gist of Pythagorean theorem and stuff like this with what's going to happen in Math 8. Thank you for watching.